Hey, welcome to The Explainer. So today we're going to look past all those headlines you see about massive data breaches. We're actually going to break down the entire playbook that hackers use to attack the digital systems you and I rely on every single day.
You know that image you have of a hacker? Some lone genius just typing like crazy to break a system in one single brilliant move? Yeah, forget that. Real-world security is all about anticipating a methodical, step-by-step process. We're going to explore the system security experts use to actually think like an attacker, so they can get ahead of the game and block threats before they even happen.
All right, so to really get this, let's just jump right into the action. We're going to use a fictional case study, a modern digital bank we'll call Banco Segura Plus. You know the type, it's slick, it's convenient, and that makes it a perfect target.
So here's the scene. It's super simple. A customer just wants to transfer some money to a friend. We're going to follow this really basic, everyday transaction and see how a hacker could try to hit every single stage of this process.
So how do you actually think like a hacker in a structured way? Well, you can't just guess where the problems might be, right? You need a system. And that's where this really powerful framework for something called threat modeling comes in. It's called STRIDE. Basically, STRIDE was created to give the good guys a checklist. It's a systematic way to hunt for those potential weak spots in a system. The whole point isn't to just react after an attack happens, but to proactively find and fix these vulnerabilities before a hacker ever does.
And yeah, the name STRID, it's not random. It's an acronym. And each letter stands for one of these 6 fundamental types of threats. It represents a different way an attacker can try to break into a system. And we're going to walk through every single one using our bank example.
Okay, let's get back to our bank. We're going to see how the first 3 plays in the hacker's playbook, spoofing, tampering, and repudiation, could actually go down in a real-world attack on Banco Segura Plus.
All right, first up, spoofing. This is your classic imposture move. The hacker's entire goal is to pretend to be someone they're not, in this case, a legitimate customer of the bank. This attack goes straight for the system's authenticity, its ability to prove that you are who you say you are.
And this is what's so powerful, right? Look at how a pretty simple defensive move can totally change the game. A weak password, that's easy to steal or guess. But the second you require another factor, like a code from your phone, using multi-factor authentication, you make it so much harder for an imposter to get in.
Okay, next play in the book is tampering. Now, the attacker isn't trying to be you anymore. Instead, they're trying to get in there and secretly change the data while it's in transit. This move is designed to undermine the data's integrity, which is just the guarantee that the information hasn't been changed without anyone knowing.
So, picture this. Our user starts a totally legit transfer for €100. That request has to travel from their computer over the internet to the bank server.
But here's the scary part. If that connection isn't locked down, an attacker can just sit in the middle, grab that request, and change the amount from €100 to 10,000. And of course, they'll change the destination to their own account. If the bank doesn't have the right checks in place, its server might just process that fake transaction with no idea the data's integrity was completely blown.
Now this third threat, repudiation, it's a bit sneakier. This is the "I didn't do it" threat. The goal is to compromise the system's ability to prove who did what. Without a solid digital paper trail, a user could make a transaction and then just deny they ever did it because the bank has no way to prove it was them.
Okay, so we've covered STR. Let's get into the last 3 letters of STRIDE. And these attacks, they're often aimed at causing much bigger problems, like stealing huge amounts of sensitive data, shutting the whole bank down, or even just taking complete control.
Information disclosure. I mean, this is basically digital eavesdropping. The attacker's goal here is to get their hands on private data they're not supposed to see. It's a classic spy move. They might listen in on an insecure public Wi-Fi network to snatch up account numbers or passwords, and that completely violates the principle of confidentiality. And here's a really important point. An attacker doesn't have to steal a single piece of data to create total chaos. With a denial of service attack, or DDoS, the goal is much simpler. Just make the service completely unusable for everyone else. This is a direct assault on the system's availability. So think about it. On any given day, the bank's servers are just humming along, handling requests from all their legitimate users. The system is available, it's responsive, it just works.
And boom, this visual just says it all, doesn't it? In a DDoS attack, the hacker uses a whole network of hijacked computers to just flood the bank's servers with millions and millions of fake requests. The server gets so swamped dealing with all that chunk traffic that it can't respond to real customers anymore, effectively taking the bank offline.
And that brings us to the last one, elevation of privilege. For a lot of hackers, this is the grand prize. The attacker finds some kind of flaw or a bug in the code that lets them turn their normal, everyday user account into a super powerful administrator account. This completely shatters the principle of authorization, and it could give them the keys to the entire kingdom.
So, okay, we've just walked through all these pretty scary attacks, from someone pretending to be you all the way to a full system takeover. So how does Stride actually help us defend against this stuff? How does it become a blueprint for our defense?
This table right here, it's basically the whole model in a nutshell. It shows you that direct one-to-one link between each of the 6 threats and the core security idea it's trying to break. So in building a system, developers can go through each part and ask, okay, how could someone spoof here? How could someone tamper with this? And then they can build specific defenses for each one.
So why does any of this matter? Well, the big takeaway here is that Stride isn't some abstract academic idea. It's a real-world, practical tool. It's a checklist that forces engineers to put on their attacker hat and actively search for weaknesses. It turns security from this vague goal into a concrete, repeatable process that helps you build way stronger systems.
And that right there, that's the real power of the Stride model. It completely reframes how we think about cybersecurity. It's not about defending against one single magical hack. It's about systematically building defenses against this known 6-part playbook of attacks.
Which kind of brings us to a final question for you. Now that you know the hacker's 6-part playbook, what other systems that you use every single day, from social media to your smart speaker at home, could be looked at through this very same framework? Once you start applying this lens, you start to see all the hidden security challenges that are all around us.